In this video, we are going to discuss about the sequential logic circuits. On completion of the sequential logic circuits, the students will be able to explain the combinational logic, and they can also find out the difference between the sequential and the combinational logic. So first, in the combinational logic, this combinational logic is nothing but it depends only on current input and it has no memory. But in the case of sequential logic, uh, this sequential logics we are saying about, it is a digital circuits that stores and use the previous state information to determine its next state. So while comparing with a combinational circuit that depends only on the current input values for producing the output, but the sequential circuits depends on both the current inputs and the previous states that are stored in the memory elements. In this sequential circuits, it is commonly used in the digital system for implementing the state machines, timers, counters, and memory elements also. We can see this memory elements in the sequential circuits using the flip-flops, and we know that the flip-flops are used for storing the binary values, and it maintains the state even the input changes from one part. And there are two types of sequential circuits. It is finite state machines and synchronous sequential machines. So this finite state machines is nothing but this has limited number of states, and also it is typically used for implementing the state machines and control system. In the case of synchronous sequential circuits, it is designed to have infinite number of states, and typically this is used for finding out the implement timers, counters, and memory elements. Here we can see the sequential circuit diagram. So this sequential circuits is having the circuits that is having learned so far is containing the information storing circuits. So here this is used for storing and use previous state information to determine the next state. This is the main thing in this one. So this is commonly used in the digital systems for implementing the state machines, timers, counters, and memory elements. Major things, these are the essential components in the digital system design, that is combinational circuit and storage elements. So this sequential circuit, this consists of input variables, logic gates, and output variable. Here this combinational circuit is mainly which is based on the input variables, but only a sequential circuit will produce as an output based on the current input and previous output values. That means that sequential circuits is including the memory elements which are capable of storing binary information, and this binary information definitely defines both the state of sequential circuit at the present time. So a latch which is capable of storing one bit of information, which we call it as the sequential circuit. And here we can see the sequential circuits logics. The concept of this one is it remember the past inputs and past circuit state, and the outputs or the feedback as new inputs, which is having the gate delay as well as the wire delay. We know it is used for storing the information. Here there are two types of inputs in the combinational logic. One is external inputs, which is controlled by the circuits, and internal inputs, which is the function of previous output state. So the secondary inputs which are produced by this storage elements will have the storage components. And here this is two types of sequential circuits. One is asynchronous sequential circuit and another one is synchronous sequential circuit. In the case of asynchronous sequential circuit, they do not use a clock signal, but they uses the pulses of the inputs. Also this is very faster than the synchronous sequential circuits because there is a clock pulse and there is a change of state, that is it changes immediately whenever we are giving the change in the input signal. So we use this asynchronous sequential circuits when the speed of operation is very important and also it is very independent, but these circuits is more difficult to design while comparing with the other circuits. And in the case of synchronous circuits, this uses a clock signal and level inputs. So this outputs can be used from the next clock pulse for arriving the best position or to perform the next operation, but it is very slower compared with the asynchronous, and also the level will be changing from the input pulse, and it remains in which state or it remains in the next state. So So here mainly you can see the advantages or disadvantages of the sequential circuits. The main advantages is nothing but memory. It has a timing, it has a state machine implementation, it also finds out the errors. Mainly in the memory you have the capability of storing the values, binary values, and also timing, it will be implementing and synchronizing in the digital system. Here this flip-flops will mainly receive the inputs from the combination circuit from the clock signal, and then it will be producing the it will transmitting the pulses in a fixed intervals of time. Each pulses will be transmitted in a particular timings. So proper timing is maintained in this sequential circuits. Major disadvantage, if you see, means it is more complexity. Why we are saying this as complexity means this contains more components to implement, and time constraints are there. That is, if you are designing a sequential circuits, it can be challenged to ensure that the timing of the inputs and outputs should be correct. Then only we can transmit the information, or we can transmit the pulses. While testing or debugging means it is more difficult while compared with a combinational circuit, because it has the complex structure and state dependent outputs. So major disadvantages are complexity, timing constraints, and testing and debugging. Quiz questions on sequential logic circuits is difference between the synchronous and asynchronous. Thank you.